Good afternoon. Can everyone hear me? Fantastic. Thank you. And can you see the Pearson Product Moment Correlation title slide? Okay, fantastic. So we are ready to proceed. Again, good evening, good afternoon, good morning, depending on where you're dialing in from. I'm Dr. Reggie Taylor from the Office of Research and Doctoral Services. And this evening, my time zone from here, St. Augustine, Florida, I'll be facilitating a Pearson Product Moment Correlation quantitative seminar. And before we get started, to give us some idea of the direction that we're moving in, I'll go over some housekeeping notes. We'll just talk about easing anxiety, what I consider to be the most important focus of these presentations. We'll talk again, as many of you have attended some of these previous sessions. I see some of the names. You'll see how important it is to understand the scales of measurement and how important it is to any and everything that we do pretty much in quantitative analysis. And we'll jump right into the Pearson Product Moment Correlation test, right into the concepts, the applications, when, where, how do we use it, and then we'll jump right into the application for those individuals that may be taking the research course at Walden, the first research course. We'll look at one of those data sets that you would be using for the Pearson Product Moment Correlation test. As we always do here, we'll take a look at an exemplar, which you'll be provided a copy. And then the upcoming seminars. Tomorrow night, we'll move right into the bivariate regression, which you'll see is just the next logical progression from what we're trying to do today. And I'll talk a little bit more about that. You'll be required to register as normal. As you can see here on the slide. So when you get the presentation, of course, which I will put into the chat tonight, you can just register there if you haven't registered already. And again, as always, the survey is what keeps me informed as to what we're doing, if it works, what needs to be done, do we need to do more, et cetera, et cetera. And as always, you can go out to this YouTube link to take a look at and have an on-demand resource at all times through your Walden quantitative journey on this session and any of the other sessions that we have conducted. Okay. So, give me just a second. So, the first thing that we do is we always talk about the scales of measurement, as they are very, very important in understanding statistical analyses. And we now know, if we've attended any of the previous sessions, that when we get into SPSS to do the data analysis, that depending on the scale of measurement of the particular variable or variables, we can do or we cannot do certain analyses. So that's why it's important for us to first understand the scales of measurement and how they are included in the SPSS output. And we talk about 4 scales of measurement. We talk about the nominal, ordinal, interval, and ratio. But as you can see in this slide here, we have some variables, and we only have 3 selections here: nominal, ordinal, and scale. But as you have seen from previous sessions, the scale variable or the scale measure comprises both the interval and ratio. So when we start looking into the data files, we'll only see 3 scales, but we know there are 4 scales of measurement. And again, the scale will represent 2 of those scales, the interval and ratio. So in essence, we have 4 scales of measurement: the nominal, the ordinal, the interval, and the ratio. Okay? Now, let's talk about this Pearson's correlation test. Now, before I get into that, if any of you have attended any of the previous sessions, you know that we started out looking at descriptive statistics. How do we describe data? We looked at visual displays of data. How do we produce certain graphs? What do those graphs mean? How do we interpret those graphs, etc.? And then we jumped into some inferential statistics, meaning running some of those statistical tests. And what we started out with was what we call group comparison tests. Okay, and I'll repeat, group comparison. And those were, for example, the t-test. For example, the independent samples t-test, we compared two groups on some outcome variable. When we did the repeated measures t-test, we compared two related groups. So we were comparing. Even when we did the one-way ANOVA, we were comparing 3 or more groups. But now we're switching that whole concept and we're moving away from comparison. And now we're moving into that family of tests where we look for relationships. Okay? So one of the very first tests that you'll come across when we're looking at relationships is the Pearson's correlation test. Now, what is this Pearson's correlation test? And remember, what's important is that we understand the conditions under which we use certain tests. And this is a test where remember, you will not see the words compare or look at groups or things of that nature. You'll see that it's used to determine the strength and direction of a linear relationship. And that's the key word. We're looking at the linear relationships between two variables, not between two groups. We're not doing any comparisons. We're looking at relationships. So that's the first thing that we want to understand when we are now looking at the correlation test. And the main things that we're looking at, again, is not comparing averages or things of that nature, but we're looking at the strength, first of all, of this relationship. And when we start looking at our output, we'll see that the Pearson's product test produces a correlation coefficient, which would be denoted by the letter R. And that R is going to tell us something about the strength of that relationship. And so we'll see that correlation coefficient will go from a -1 to a +1. It can only range between these values. Now, what we look at when we talk about the strength is that a value from about 0.1 to 0.29 is what we consider small. And disregard the negative or the positive because it means the same thing either way. We get a medium to a moderate relationship when we get to 0.3 to 0.49, and anything 0.5 and greater is a large or strong relationship. So as we did with other tests, when we start looking at the output, we will now be able to understand the strength of the relationship. And the direction is simply meaning, is it a positive relationship? Is it a negative relationship? Or perhaps it may be curvilinear. And we'll take a look at some of these examples. Or it may not be linear at all. So again, as you can see, we're looking for two components. The strength of the relationship, which will be denoted by the R value, and the direction, which simply will be, is it either a negative or positive relationship? Okay? Now let's look at this pictorially. And remember, we had started looking at visual displays of data so that when we start looking at output in charts and graphs, it can help us understand the strength and even the direction of the relationship. So let's look at those 4 relationships that we just talked about and what it may look like in what we call a scatter plot. The first one on the left here, as you can see, is what we call a positive relationship. And we kind of see the way the data is plotted here. and this little red line is kind of superimposed. If I were to ask you all to draw a line through a straight line through these dotted points here, we all may draw something a little differently, okay? But again, as you can see, the general direction is going from bottom left to top right, what we call a linear relationship, and it's positive. But we may have a linear relationship, but it may be negative. In other words, if something goes up, something else goes down. Or it may not be linear at all. For example, it may be curvilinear. Okay? And it may be nonlinear at all. So we will learn how to look at some output to determine the direction of the relationship. Now, let's take a look at the scenario, first of all, that you will be faced with if you're taking the research course. Now, again, you're going to write a paragraph 2 to 3 analysis of your correlation. And remember, and bivariate regression results. This day, tonight, we're only going to focus on the correlation. Tomorrow night's session, we'll focus on the bivariate regression results. Now, and again, we're going to report the assumptions surrounding these tests and the effect size. And remember, we've done this before. And remember, we talked about the meaningfulness of the results. Remember, we talked about testing the assumptions to make sure the data meets the assumptions. We then have to assess those assumptions. If they're violated, we have to tell the reader what we're going to do. And then we run the results. But one of the critical things to report, in addition to the p-value, is the effect size. And we're going to go through that. And you'll see that in the exemplar again. Now, let's talk about the data assumptions. As you recall, because this is what we call a parametric test, meaning that it comes with data assumptions, and we've looked at other data assumptions. And if you recall, for the t-test, all of those had outliers that we were concerned with. And also, those tests also had the normality assumption. But one of the things that differs in the correlation test is the linearity assumption, because what is the test all about? It's assessing a linear relationship. So ideally, we must assume and hope that the data is linear for us to be able to run the test. And as we have done with the other sessions, we will look at how we assess outliers, linearity, and normality. Now, what are these data assumptions? Now, we also have some requirements for the test that I'm going to talk about first. And again, design-wise, meaning that when we go into the data set and we look into that data set, you must select, and I'm going to repeat, you must select 2 continuous variables, meaning they're either interval or ratio. And remember, in SPSS, that will be represented by a scale variable, and we'll take a look at that. And the example that we'll work with is the relationship between optimism and life satisfaction. And one would normally think that if we're more optimistic about life, it should be related to our life satisfaction. So that's kind of the conceptual issue, but any 2 variables that make sense of looking at the relationship, and if they're scale or numerical variables, those are the appropriate variables for the Pearson's correlation test. You won't use a nominal variable, for example, a categorical variable. You won't use that. You have to have 2 scale variables, and we'll take a look inside the data set and make sure we understand exactly what we mean by that. And also, design-wise, these 2 variables are paired, meaning that the data from optimism is coming from the same individual that gave us the life satisfaction data. So if you were conducting this research, you would ask your participants to give you their rating of their optimism and their life satisfaction, okay? But then we know that when we go to do data analysis, that we are concerned, first of all, with the data assumptions surrounding our test. And for the Pearson's correlation test, we are concerned with making sure that there are no significant outliers. We also assume that there's a linear relationship between these two variables. And we also assume that the data is normally distributed. And you may recall from the previous sessions, and you'll see that it doesn't really change. Remember when we looked for outliers in our t-test, what did we look at? The box plot. The same thing we'll do for the Pearson's correlation test. We're going to look for linearity. Now, we didn't look for that in our other tests, but we'll look for that. And you all are very familiar with a scatter plot, and we'll take a look at scatter plots. And we're going to look for the normal distribution. And recall for the t-test, we also did that by looking at the Shapiro-Wilks test. So if you've attended the previous sessions, you have done this before, and you should become very comfortable with this and understanding the flow of the process, identifying the assumptions and then testing the assumptions. Okay? Now let's take a look at the output for these assumptions. Now, if there's anyone that attended the previous sessions, what we're looking at here now are box plots. This is a box plot of life satisfaction, and this is a box plot of total optimism. And we know that when we run that box plot, that when we look at it, that what we are looking for are the little dots. And we see that we have two dots here. And we have the numbers 81 and 276. That tells us that we have two outliers. Notice we do not see any of the little dots around the total life satisfaction variable. So what it means is that for optimism, two cases, two individuals really scored outside the norms. They were extreme outliers. And we know that those are things that we really do not want in our data, because they really can change the correlation coefficients with regression or correlation tests. So we have identified that we have two outliers. Now, but we also are concerned with linearity. Remember, and we said the scatter plot. We'll run a scatter plot. And as you can see here, the little line that I've drawn is superimposed. I drew this here. But this is what happens. You look at the data, and you're going to be able to see if there's a linear pattern. And this is clearly a linear pattern overall, kind of going from lower left to top right. So we would say that this assumption is met. But then we have the final assumption of normality. And remember, we do that by the Shapiro-Wilks test. And we'll take a look at all of this, how to run it. But remember, the test of normality is going to be a part of the output. And we're going to look at the Shapiro-Wilks area, and we see that it is less than 0.05, meaning that this is a significant deviation from normality. So in this case, we violated the assumption of normality. So this is how we look at the data to make sure that we understand how well the data aligns with the assumptions that it should meet. Now, after we do that, we then say, okay, now what we have to do is now run the test. A research question can and should be perhaps as simple as such. Is there a relationship between optimism and satisfaction? As simple as that. The null and the alternative hypotheses are, again, that there is no relationship, and the alternative always that there is a relationship. And in quantitative research, we know that we are trying to find evidence to reject this one and say that we accept this one, that there is a relationship. That's what we're trying to do, again, conceptually, just as we've done with all statistical tests that we have looked at thus far. The important thing to understand about the Pearson's correlation test, that there is no distinction between independent or predictive variables and dependent variables. When we look at these variables that I have in green, optimism and satisfaction, there is no such thing as one is an independent and one is a dependent. We are simply saying that we're looking to see if they are related to each other. Okay? In the other test that we did, we stated, for example, gender is the independent variable. This is the dependent variable. We do not have that distinction with the Pearson's correlation test. We simply want to see, are these two variables related to each other? One doesn't come before the other, okay? That's important, and that's why I put that in red. Now, how would we do this in SPSS? And again, remember, as we always do, we'll go live into SPSS, but as you realize from all the other tests, we always start out in the analyze area. Correlation, correlate. This is exactly what we're getting ready to run, a correlation test. Remember, before when we ran t-tests, we compared means. We're going to come down just to the correlate, and it's going to give us selections. We're going to do what we call a bivariate. That means there's two variables, and those two variables will be total life satisfaction and total life optimism. Remember, the research question was, what is the relationship between satisfaction and optimism? Now, note, remember the little rulers that we see before the word total? Those are scale variables. That means that's a scale variable, meaning that that variable is appropriate for the Pearson's correlation test. Remember, we said it has to be two scale variables. We couldn't use sex. That's a nominal variable. We couldn't use marital status, etc. Okay? We would then select options. And this is where, where we would tell SPSS the options that we want. And you see here it says options. And again, we just want the means and the standard deviations. Remember, these are numerical data. So we always want to know what the average optimism score, what the average satisfaction score, and what those standard deviations were. Remember, descriptive statistics. We hit continue. And remember, we always want our 95% confidence intervals. And when we hit continue, we're going to get output. And the output is what's important for us to understand. And this, again, is where it all boils down to answering that research question. Is there a relationship between these two variables? Now, the first thing I always tell the individuals to do is just kind of sit back, take a moment, and look at the output. Don't let it overwhelm you. Just kind of look at the wording and look at what you see here, okay? Now, the first thing we'll see, if we start up top, is that we have descriptive statistics. And remember, we have to describe the data. You know, in other words, the average scores, the standard deviations, etc. And remember, those are right here for total life satisfaction and optimism. And so we see the average scores and the standard deviations. This is the information here that answers our research question. And as we can see, we have total optimism starting over here, and we're looking for the Pearson's correlation. with total life satisfaction. The correlation coefficient, remember I said it goes from a -1 to a +1, is a 0.480 right here. Is that significant? We look at the sig column, to tail, and is that a significant relationship or not? What would you say here? Is there a significant relationship between optimism and satisfaction? Yes, it is. Because the sig value is less than or equal to 0.5. The N is simply was the sample size. Okay? A very simple test. Remember, but what we want to understand is how to look at the output and to interpret it to be able to answer that research question and to determine if we reject or if we accept if we reject the null hypothesis and accept the alternative. And in this case, we would, because it is a significant correlation. And then the second line is just actually the opposite. We're looking at total life satisfaction and seeing if it's related to optimism. And again, we see the same correlation coefficient. It's no independent dependent. These are going to be exact identicals. And again, it's significant. And again, the sample size. Now, remember the other important information is the confidence intervals. We know that the correlation is 0.480, but we know that what the 95% confidence interval means is that if we were to conduct this study 100 times, pull a random sample from the same data set, then 95% of the time that the true Pearson's correlation will be as low as 0.404 and as high as 0.549. So this 4.480 kind of sits right here, and we're saying it will be as low as here and as high as here. Again, that confidence interval, which gives us a lot more meaning than the significance value. Okay? Now, what would that look like once we say, okay, we've got the results, and let's go ahead and let's write this thing up. Now, again, this is the confidence interval slide. I just wanted to show it by itself. As you can see, the correlation coefficient. Now, remember, we talked about strength and direction. This is positive because we don't see a negative sign. So we know it's a positive relationship, meaning that as optimism goes up, so does life satisfaction, or vice versa. As satisfaction goes up, so does optimism. Now, the strength, remember, if we looked at the table, we would see that this is a medium to moderate strength. And we know that it's significant. And again, these are the confidence intervals. So again, as you can see, we understand now and have all the information that we need to answer our research question and to turn this into an APA results write-up. Okay? So let's take a look at that. Now, here we go. As we always do in our other examples, we just simply always state what we did. We did the Pearson's correlation test. And again, examine the relationship between optimism and satisfaction. And again, I put amongst Walden students. Remember, we must always then assess our assumptions. So we said the preliminary analysis were conducted to examine the assumptions. Remember, the 3 assumptions were outliers, which we examined through the box plot, linearity, which we examined through the scatter plot, and normality, which we examined through the Shapiro-Wilk test. And we're going to tell the reader exactly what we did by mentioning all of those tests. So Figure 1 is a box plot identifying 2 optimism outliers. Remember in that box plot that we looked at, we had those 2 outliers? But what I'm saying in this example, these outliers were removed in the final analysis. So that's the decision that the researcher makes about how to handle those outliers, okay? Now, the next assumption was linearity. And we say the assumption of linearity was met, and we have a figure 2. And what that figure 2 will be the scatter plot that we looked at. And then we say, finally, the normality assumption was not met. And how do we know that? Because we looked at the Shapiro-Wilks test, and we saw that the p-values were less than 0.05 for those two variables. So you see, we did something, and then we just told the reader what we did. So now we understand how the data aligns with the assumptions and what we did. Then we go and we report the results of the correlation test. And in this case, remember, they were significant. And before, remember, we had T in front of here for t-test. We had the F for the ANOVA. But what we are doing now is a Pearson correlation test, and it is denoted by the R. So if we look in literature and we see the R, we should know that a Pearson's correlation test was done, even if we don't see the words Pearson's correlation. Anyone want to take a stab at what the 433 means inside the parentheses?
Sample size.
Exactly, sample size. And in this case, we don't do the n-1. It's just a different process. And this is actually the actual true sample that was used, 33. And then remember the 0.48, that was the correlation coefficient that was calculated. And we always report the 95% confidence intervals for that. So we know now that 0.480, the lowest it could have been was 0.40, and the highest upper limit 0.55. And we know that the Pearson test was significant. And we make a final statement. The null hypothesis is rejected, saying that there's no difference, and we accept the alternative, saying there is a small positive relationship between optimism and satisfaction. Now, recall from the t-test, the ANOVA, that we had to also report the effect size. And remember, we reported Cohen's D. Well, for the Pearson's product moment correlation test, we don't worry about Cohen's D. We worry about something called the coefficient of determination. And that's the same thing, the effect size. And that was 0.23. Now, how do I come up with 0.23? You see the R value of 0.48 right here? To come up with the coefficient of determination, we simply square that number. And you can see I have in parentheses 0.48 squared. And if you did the math, you would see that's 0.23. And that says that these two variables share 23% of the variance. And then you would have a table 1 for descriptive statistics. Now, what I want to do at this point is give me a second, and I just want to kind of put this into, let's take a look at the exemplar, and you'll see it now kind of here in a format that it would be presented, not in a slide format. So again, if you've looked at these exemplars before, this one is for the Pearson Product Moment Correlation Test, okay? And, I have a forward here, and I tell you, that this is there's no prescriptive response or way to present this, but this is pretty much contains all the requirements that are needed. A faculty member may want something different. A committee member may want to see some things put in a different format. But in essence, this is what should be submitted. Now, if we would do a purpose statement, we would see the purpose of this study is to examine the relationship between, and as you can see, here are the two variables, optimism and satisfaction. That turns into a research question, which is the exact same thing, alignment. Is there a relationship between optimism and satisfaction? No hypothesis, there is no relationship. There is not a relationship. alternative, there is a relationship. Now, for an application assignment with those individuals that may be taking the research course, you have to show a little knowledge and understanding of the test, etc. And here, as you can see, I'm defining and describing what the test is, and I'm providing a citation. And as you can see in this session, I'm just meeting the requirements of showing that I understand the appropriateness of the test, when it's used, why it's used, and why it's appropriate for this particular set of variables that I have selected. Then you just simply have to present the results as we have done in the PowerPoint presentation. And again, I did the same thing. And as you can see, I talk about, the cases 81 and 276 were outliers, and I say they were removed. And then I go on again, I talk about the normality tests and then the results. Now, for an application, you have to put, and I tell you that I have the box plot as figure 1, and as you can see, showing the 2 outliers. Here is my figure 2 of the scatter plot. And here is my table 1 showing some descriptive statistics, the averages of the 2 and the standard deviations. And when you are required to provide the output, as you can see, I provided a little table here that shows that these are the components that you should have in your output. And those components are plugged in here to show you, again, the test of normality, the descriptive statistics, the correlations, and the confidence intervals. And that would meet the requirements of showing that you have ran the test, you have created an APA results output based on the output here, and everything should align. So what's included in your narrative output up here, again, and all of this information here, should be supported and aligned with what you have put in your output. You really are taking your output to inform your input in your narrative, okay? Now, sometimes you'll see that, it used 434 that it calculated descriptive statistics for. But you can see this says 434, this one says 433. And probably that's just a matter of missing data and how SPSS handled, one of the missing pieces of data. And that wouldn't be too much to worry about. You'd have to look into the data set to see exactly what's going on. And that depends on how you handle missing data. So that's a little bit beyond our scope here. But let's do something here now. Now, what I have here is that I've opened up SPSS here. And I'm going to open up the data set that we just looked at and show you kind of how we looked at what we had there. Now, remember, we looked at the relationship between optimism and life satisfaction. And here are these variables right here: optimism, and total life satisfaction. And this is how they were labeled. Remember, we're in the variable view. I'm sorry. Here. And if I go to the data view, you'll see that the individuals had an optimism score. So person number 1 had an optimism score of 22. Person number 1 had the life satisfaction score of 23. So what we're doing as it relates to the research question is trying to see if there is a relationship, between these two variables, total optimism and life satisfaction. Does everybody see that? Now, what I want to do is let's take a look at the variable view and let's take a look at those variables in terms of the scales of measurement, okay? Now, give me just a second. Now let's take a look at this. Look at total life optimism. You see that scale of measurement there? It's a scale variable. Make sure that when you go into the data set to run this test, that you have two scale variables in this measure column. You see total life satisfaction. It is a scale variable. And again, remember, nominal, ordinal, and the scale represents interval or ratio. Make sure you're using two scale variables, okay? That's important. And as you can see, what I can do here is I go up into analyze, remember, correlate, bivariate, and I'm going to put the two variables of concern here. And remember, they must be the scale variables, okay? And there we go, the two scale variables. Remember, we're doing the Pearson's test. It automatically defaults to this. So don't worry about that. Leave it two tails. And then on the options, remember the means and the standard deviations. And when we hit OK, we'll get the same results as we did on the slides. And as you can see, the Pearson's correlation, significant, 0.001. Remember the correlation coefficient, here the descriptive statistics, etc. That's how the testers run. The exemplar should be very helpful to you. And now repeating the steps to run the Pearson's correlation. So does this make a little bit more sense now to everyone than perhaps it did maybe 30 minutes ago?
Yes.
Okay. And have we kind of eased the anxiety just a little bit? I know that it's a lot to come in 30 minutes, 45 minutes, but the idea, remember, you're going to have the slide presentation to use. You're going to have the video to look at, to stop it, to go back. But the next thing we're going to do to add a little value to this is to now take a look into that actual high school long data set to make sure, again, we understand what that data set looks like, if that's the one you're going to use, and make sure we see the variables so we kind of understand how that applies to the Pearson's correlation test, okay? So give me just a second here to find that data set. Okay, now that HS long data set, I have that open, okay? Now, the first thing that we know is that when we look into the measure column, that we have to look at and identify the scale variables. It has to be two of these. You know, you have some scale variables here. For example, I'm going to highlight here. These are some scale variables. So these are what we're looking for, first of all, to make sure that we utilize, okay? If you scroll down, here's a couple of scale ones here. And again, what we want to look at is in the label to see what it's really asking, because here in the name, that's not really explanatory. I don't know what that name means. And so a lot of times when you really understand the variable and what they're asking and what they're collecting is in the label column. So let's come up with the research question. If I know that these are all scale variables here, I'm going to go from here to here. I could say, what is the relationship between the student's mathematical identity at time 1 and their mathematical utility at time 1, whatever that means. But you can see those are two variables. They're both scale. Or, for example, what is the relationship between the student's science self-efficacy, right here, the student's science utility score, and the student's science self-efficacy score? Does everybody see that? What I'm doing there and how am I going into the data set? And of course, you want to make sense of it, and you would turn it into the research questions, use the exemplar example, and then go through the steps and report the results. Okay? As simple as that. You're looking for the scale variables. Okay? Now, for example, what is the relationship between the student's mathematical identity and the student's mathematics utility? Let's just take a look at two of these, just to do it. Analyze, correlate, bivariate. Let's look at science identity and science utility. Are those variables related? And we'll go into the options, remember. We'll run the means and standard deviations, continue, and let's see what the results say. You tell me, is there a relationship between the students, we're looking down here, between their science utility and their science identity? Yes or no? Yes, it is. What's the Pearson's correlation coefficient? Exactly. Now remember, I didn't select the confidence intervals in that example, so I will go to analyze again, the correlate, the bivariate, and they should still be sitting here. And then again, confidence intervals, and then again, let me select that. And now we'll get to report with our confidence intervals. So you see the correlation 0.435, but now we know it could have been as low as 0.407 and as high as 0.461 with a 95% confidence interval. Does everybody see that? Fantastic. And that's all it is to the correlation test. Now, I want to do one other thing. I'm going to open up the Afrobarometer data set. And again, just to take a quick look in that data set, if that's the one you choose to use. And then again, what you're going to do is, again, remember the label kind of gives you what they're asking for. And you're going to be looking into the measures column. And I just like to move it over here. And I'm going to be looking for scale variables. So for example, here, is there a relationship between age and what's that number of adults in the household? I mean, I don't know. I mean, use something that makes some logical sense there. Let's try to find some more scale variables. Here's a bunch of scale variables here, okay, in the Afrobarometer data set, okay, that I've highlighted. So as you can see, they're asking for, okay, is there, excuse me, this. Now let's look at here. Is there a relationship between level of democracy today? That keeps sliding on me for some reason. And the level of democracy 10 years ago, or whatever that data set. Let me go down to the excuse me here. Got a lot of windows open. Data view. Okay, so here's the data. And again, as you can see, that they are looking at, again, the level of democracy, et cetera, variables here, their satisfaction with them. But what you want to do is get into the variable view so that you find those variables that were the scale right here. So question 46A, 46B. So for example, 46A and B is where you would be. Let me get back to the variable view again. So whatever that 46A and B, these are the ones that you can look at the relationship between whatever is in 46A, and I'm not sure why it keeps skipping on me. But for example, what is the relationship between the level of democracy today and the level of democracy 10 years ago? Does everybody see that? Or what is the relationship between democracy
I'm
today
just going to watch this later.
and democracy in the future? Again, two scale variables is what you want. Okay. Now, this is the data set. I don't put this data set together. This is the data set in your classroom, but you're looking for two scale variables that make sense. And you're just looking to see if there's a relationship between those variables. I mean, it makes logical sense to me to see what one thinks about the level of democracy today. Is that related to what they thought 10 years ago? It makes logical sense to me. So just use your common sense and come up with a logical relationship and run the tests and report the results. Okay? So we've looked at both of those data sets. We have the exemplar. And now let's take a look for tomorrow night. What we have is the bivariate regression session. And this is how you register. Now, what happens in the bivariate regression session is that the Pearson's correlation test is extended. And what I mean by that is that we now have what we call independent and dependent variables. So you will determine and identify if optimism is the independent variable or is satisfaction, vice versa. And we now will be able to get a better understanding and be able to predict. I repeat, be able to predict one from the other. So as you can see, we're starting to go in a hierarchy of order in terms of these correlation or prediction tests, okay? So when you get the presentation, if you haven't done yet, go to this link and you'll be able to register for tomorrow's session. And finally, if you please, again, go out and take the anonymous and confidential survey. This really helps shape the future directions and the continuance of these sessions. And in summation here, again, hopefully we have eased anxiety a little bit. Do you think we have done that? I'd like to see in the chat what your thoughts about that are. We know, again, the scales of measurement are so important to understand. We know we have to use two scale variables. We went through the Pearson's correlation test. We know there's no distinction between independent and dependent variables. We're simply looking at the relationship between those two. The correlation test tells us about the strength and the direction of that relationship. The exemplar I'm getting ready to put into the chat that you can have to use. The presentation is getting ready to go into the chat. You have the registration information for tomorrow's session, the link to the survey, and more important, hopefully by tomorrow morning, you'll have the recording link out here to this YouTube channel of mine. And what I like to do is right now, go to this channel and just kind of show you where all of these videos are being housed. So as you can see, if you've missed anything, you remember all of the t-tests that we've conducted, etc., the ANOVA, the independent samples, the repeated measures. Tomorrow, sometimes the Pearson's correlation test will show up here also, okay? So, having said that, give me just a second here. That's all that I have, and what I'm going to do now is get here into the chat and put these documents in the chat. So, give me just a second here to do that, okay? Okay, you should see the presentation in there now. And now I'm going to go for the exemplar. And please check in there and you should see the exemplar now in the chat. Does everybody see those? Okay, fantastic. And yes, I see there's a question in the Q&A. I don't know what you're saying about, but you also have other scale data that isn't labeled. But again, remember, these aren't my data sets. But again, if they are a scale of measurement, it has to be a scale in there. And if the scale teaches self-efficacy and years teaching, I think that would be appropriate. Yes, and very doable for a Pearson's correlation test. Again, as long as the scales of measurement, the measurement column said scale. Yes. Okay, so again, does everyone see those presentations and those documents in the chat? Because once we close the class, we won't have access to that. And if not, you can always send me an email and say, I need this document or that document, and I'll get that to you, okay? So, other than that, that is all that I have. And I thank you for your time and attendance. And again, hopefully this has been very helpful to you. And again, remember, tomorrow night we'll follow up with the bivariate regression session. Again, which if you've attended this session, it's going to be very, very easy to understand because all we're going to be doing is now being able to predict one from the other. And we can't do that with Pearson's. We can just say there's a relationship. But we'll be able to even get a little bit more specific and say, if I know the value of their optimism score, I can tell you the value of their satisfaction score. Okay? So again, I'll leave the classroom open here for a few minutes so that everyone can get any information out of the chat they need. Okay? And so I thank you for your time and attendance, and please take the opportunity to complete that survey for me. And hopefully I'll see many of you tomorrow night. If not, the recording will always be available for you to review if you're not able to attend any of the sessions. Okay, so thank you.